Hey kiddos, this is your last integration technique, and I think I can get it all into one video, so there won't be anything new tomorrow. Tomorrow we just get to review. Here we have partial fractions. So partial fractions are going to take a lot of algebra skills that you already know combined with a little bit of calculus. So this is typically one of my students' favorites, so I saved it for last. If you find it in your flow chart, notice that this is in the bottom chunk of options because we are dealing with a rational integrand. However, it's not an improper rational. The top is not bigger than the bottom, and I don't want to do completing the square on it to look for an inverse trig. So this denominator factors. So we're going to perform partial fractions. The act of partial fractions is just an algebra technique. So I'm going to pull it out of the integral, and I'm going to show you partial fractions here. And then after we do our rewrite, we'll put it back in the integral. So this is like when you do division, and then you put it back in the integral. The rewriting of it is just an algebra technique. So here's what we're going to do. We need to factor this. So it's important to me that you know how to factor. And 2x times x is 2x squared. They both need to be 1s because 1 times 1 is 1. This is going to be the positive. This one's going to be the negative so that I get a positive 1x when I multiply out. Here's what we're going to do. We are going to pretend that somebody, that nobody ever put this together with a common denominator. So before this rational expression was put together with a common denominator, it looked like this. It had something over 2x minus 1 and something over x plus 1. And if I can just figure out what those somethings are, I can split this back up into its linear pieces, and then they're really fast integrals. So to put things together, so this is going to feel weird because I just ripped it apart and I'm going to put it back together. So to put it back together, we need a common denominator, and it's that. And to create that common denominator, a has to get multiplied by x plus 1. B has to get multiplied by 2x minus 1. So if you notice the equal signs I wrote throughout, this equals this equals this, now I have a situation where my denominators are the same, so my numerators have to be the same. And that's the algebra we're going to go do. So I'm going to write it this way. Ax plus 1 times b, or plus b 2x minus 1 has to equal 5x minus 4. And now I need to go find what a and b are equal to. And there are two methods to go about this. I will show you both, and then I'll tell you my favorite. The first way is to match coefficients. So I'm not going to, but you could multiply this out, multiply this out. And when you do multiply it out, you would have an ax and a 2bx. So if I'm matching coefficients, then those two like terms added together have to equal 5x. So now I know that a plus 2b equals 5. And then I would do the same thing for the constants. So my other piece would be a minus b, and that has to equal -4. And then I have a system of two equations, two unknowns. I can do elimination or substitution or whatever you want. That's option 1. Notice that I'm not even finishing it because I don't like it that much. Your other option is something called, well, I guess I don't really know what it's called, but it was discovered by this guy named Heaviside. So I call it Heaviside. What you're going to do here is you're going to go replace x with a number. And x is just a placeholder, right? So you can pick any number you want. The equation still has to be true on both sides. So I'm going to strategically choose to let x equal -1. And when I allow x to be -1, this term with a goes to 0. When I plug in down there, I'm going to have -2 minus 1 is -3b's. Has to equal -5 minus 4 is -9. B equals 3. And then I will strategically choose to let x equal a half so that my term with b in it cancels away. And that would give us 3 halves a has to equal, let's see, 5 halves minus 8 halves is negative 3 halves. So I'm getting that a has to be negative 1. All right. If we put it all back together where we found it, then what we've got here, I'll put it down here. This is the piece I'm looking at. So a, which is negative 1 over 2x minus 1, and b, which is 3 over x plus 1. So you have taken this rational expression and you have split it up into its individual pieces and made it partial fractions. That is something that you can integrate without any trouble. So it's all algebra, guys, and you like those better. I don't know if you know you do, but you do. I'm going to write it this way because I like a minus in the middle instead of a negative on the front. This is just me rewriting the question. All we've done is rewrite the question. Now we have to take the integral. All right, we've got 3 natural logs of x plus 1 minus 1 natural logs of 2x minus 1, and then be careful to undo that chain rule and get a half on the outside. The end. If that was too fast, if the taking of those integrals was too fast, then where you need to go is back to substitution. U substitution, that's all those were. And they're U subs you can do in your head. This would be a U equal 2x minus 1, du equals 2dx, so I have to multiply a half on the outside. The integral of 1 over u is natural log. That's all I'm doing. These are all, like, they all look the same because you're always going to be able to factor it into linear binomials. So they're always going to integrate into natural logs because that's what linear binomials do. So I guess I should take this one step further because you know how AP loves those log rules. This could be the natural log of x plus 1 cubed, and this could be the natural log of the square root of 2x minus 1, and then I could put them together in a single quotient. Oops, bars. And then square root 2x minus 1. So just be on the lookout. Your answer choices, if you get multiple choice, are probably going to look more like this than, well, that's not true. I've seen it both ways. Just be comfortable. All right, kids. So you've got Delta Math for this. You've got 5 partial fraction questions. And then tomorrow's Delta Math is a review of all different kinds of integration. So if you don't like to procrastinate, and I'm talking to like 2 of you right now, then you can go ahead and do Tuesday's Delta Math as well. All right, let me know if you need anything.